Good day, everyone. Welcome to the STEM Lockdown Digital School. This is Grade 8 Natural Sciences. I am your presenter, Onkarabetse Setswe. You guys can get hold of me on Twitter at onkarabetse_s. Right, so I believe everyone had a wonderful weekend. And yeah, let's get ready for natural science. Okay, so guys, last week we looked at atoms, right? We did revision on matter and materials and we looked at atoms. We also covered the particle model of matter. We looked at the change of state, density, mass and volume, expansion and contraction, as well as pressure. And Friday we played Kahoot. And again, well done to the top learner in Kahoot. Guys, today we'll be looking at chemical reactions, okay? So we're basically looking at the reactants and products that make up chemical reactions. So remember, guys, if you do have any questions, you can post them in the group chat or alternatively raise your hand. Okay. Right, so after this lesson, you guys should be able to define a chemical reaction in your own words. You should be able to define a product as well as a reactant. You should be able to explain what a chemical reaction is. Okay. So guys, chemical reactions, these are just key questions that we are going to answer throughout this lesson. The first one is, what is a chemical reaction? The second one is that what happens to atoms and the bonds between them during a chemical reaction, right? And then how can we identify the reactants and products of a reaction? Another thing is, what are examples of chemical reactions that are in indigenous practices? Okay, so guys, just to hear from you, what is a chemical reaction? When we talk about a chemical reaction, what are we referring to in terms of the natural science? Guys, can you use the group chat to send through your answers? Or alternatively, raise your hand. What do we mean when we say that a chemical reaction is taking place, or what does the word chemical reaction refer to? Please do use the group chat to send through your answers. Or alternatively, raise your hand. Okay, I am not seeing any answers in the group chat, so host, I think the chat is disabled and we can't send through answers in there.
Okay, the chat is not disabled. Everyone can send messages.
Oh, okay, because I can't see
No one is sending messages.
Oh, okay. It's on now, I can see it, thank you. Right, guys, can you please just resend your messages again? I couldn't see them. Okay, Natalie, I see that you say you are not sure. All right. Did we have any previous answers that I did not see? Can you just please resend them? All right, guys, so I'll just give you the answer to this now. So in chemical reaction, this is basically when one or more parts of a chemical compound interact with one or more parts of another chemical compound and they react to form a new substance, right? So the substance that they form is different from the one that we originally had, okay? So guys, basically chemical reaction is what happens when we get chemical changes in substances, and these take place during chemical reactions. So a chemical change occurs when we have a chemical reaction taking place. All right. So we're just going to do a quick activity, basically to differentiate between physical change of a compound or substance and chemical change of a compound or a substance. So this activity, we got it from the Siafula textbook, and it reads as follows: the difference between physical and chemical changes. Instructions: below is a table with some different chemical and physical changes listed. You need to decide whether the change is physical or chemical and write the answer in the last column. So you guys are just going to use the group chat, okay, to send through your answers. And I would request that the settings that you put on the group chat, do not send it to me personally. Let it be to everyone, all right? Send to everyone the answer. Okay. So the first question is, when we cut up potatoes into cubes, is that a physical or a chemical change? Is that a physical or a chemical change? When we cut up potatoes into cubes. Okay, so I see an answer from Mike, Avi, Wechedza, Therese, and Disedi, who say it is physical. Let's see. And that is correct. It is a physical change. So when we boil water in a pot on the stove, is that a physical or a chemical change? Boiling water on the stove, is it a physical or a chemical change? So your viewer says chemicals, Amabusha says physical. Bushle says physical. All right. So most of the answers, or rather, it is actually a tug of war. half of you guys are saying physical, and half of you guys are saying it's a chemical change. All right, let's see the answer. It's a physical change, right? So remember now, the water that you are boiling is just changing state. It is moving from a liquid state into a gaseous state. All right. Then third question, frying eggs in a pan, is that a physical or a chemical change? Frying eggs in a pan, is that a physical or a chemical change? See, Bushe says it's a chemical, and Tlantla says it's physical. Then Natalie also says physical. You say it physical. All right, let's see what the answer to this one is. See, Mike, you saying it's chemical, right? So the answer is a chemical change. And the reason for this is that the egg proteins undergo a chemical change. So there is bonds which are breaking, and we also have a cross-linking which form a network in the egg. And hence we say that it is a chemical change, all right? So remember, bonds are breaking within the egg, and that is why we are saying that it is a chemical change. Right, and then the next question, whipping egg whites. If we whip egg whites, is that a chemical or a physical change? Okay, I have Nhlanhla physical, all right. Okay, let's see if whipping egg whites, is it physical or chemical? So that is a physical, né, guys? Because the only thing that we're doing here is that air is basically being forced into the liquid, all right? There's no bonds which are breaking or which are forming, all right? So whipping egg whites is a physical change, right? And then dissolving sugar in water, is that a physical or a chemical change? Dissolving sugar in water. Yeah, I see chemical. Okay, I see Mike says physical. Tyrese also says physical. All right, let's see the answer to this one. So guys, it is a physical change, and I do understand why most of you guys said chemical, because you think that the molecule of the sugar is changing, or molecules of sugar is basically attaching itself to the molecules of water, and that is not the case, guys. So what happens when we dissolve sugar in water is that sugar grains are dispersed, right, within the water, but the individual sugar molecules are unchanged. And remember, we can separate our water and sugar via distillation. So if we can boil the water, right, the dissolved sugar and water, if we can boil it and all the water evaporates, the sugar crystals will remain behind, and hence dissolving sugar in water is a physical change. All right, I hope everyone is understanding. Okay, beautiful. Then burning gas in a gas cooker, is that a physical or a chemical change? Burning gas in a gas cooker. Yeah, Siubuhle says chemical, Aviwa chemical. All right, do you have any more answers? Tyrese physical, Liseti chemical, Mike chemical. All right, let's see the answer to this particular question. So that is a chemical change. All right, so burning gas is a chemical change because the water vapor and carbon dioxide are released. Okay, we have water vapor and carbon dioxide, which are released. And then third last, your ice cream, which melts in the sun. Your ice cream melts in the sun. Is that a physical or a chemical change? Ice cream melting in the sun. All right, physical, physical, physical. Okay, sorry guys, that is my mistake. It is indeed a physical change. All right, it is a physical change. And then the next question, milk turning sour. You have milk turning sour. Is that a physical or chemical change? Yeah, I see chemical, 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 beautiful guys. And you guys know why the milk turns sour. You guys know why this milk turns sour. Okay, Natalie, you said physical. So milk turning sour is a chemical change, ne, guys? Milk, okay, Shantla says it expires. Okay, all right. Okay, milk turns sour because there is a lactic acid forming. All right. Yes, it does expire, and that is because there is lactic acid forming in the milk. All right. Then lastly, an iron gate outside rusts. An iron gate outside rusts. Is that a physical or chemical change? I see chemical, chemical. It's from Huawei, Tyrese, Ntlantla, Mike, Lisedi, Zamagushe, and Bushe. All right, beautiful guys. So that is indeed a chemical change, right? Because the metal is basically reacting with the oxygen outside. All right. Okay, then we can continue. Let us look at reactants and products. So guys, from here, we can basically differentiate between physical changes and chemical changes that take place, all right? Remember, we said physical change, a composition of compounds stays the same. And then in a chemical change, the composition of compounds change, right? So we either have the breaking of bonds or the making up of new bonds. So guys, let us look at reactants and products. So reactants are substances used during a chemical reaction. All right, so we can basically think of reactants as ingredients that we use for cooking, right? If you wanna bake a cake, for example, you would use your flour, your water, your baking powder, and all of that. So that would be referred as to our reactants. And then the final product, which is the cake, would be our product. Okay, so similarly in chemical reactions, that is what's taking place. So reactants are substances that are used during chemical reactions, and then products are substances produced after a chemical reaction. So here in this picture, guys, we have an example of sodium metal and chlorine gas, which are our reactants into forming salt. All right. So remember, you should be able to define a reactant and you should be able to define a product. All right. Okay, and another property of chemical reactions is that atoms are getting rearranged, all right? Reactant atoms are rearranged. And here we have an example of the formation of carbon dioxide. So guys, the gray circle there, it is indicating our carbon atom. And then the two red circles there, they are indicating our oxygen atoms. And then we have a formation, if I can just show you guys here. Then on this side here, we have our product. All right, and that is our carbon dioxide, which is indicated with CO2. Okay, so this is the carbon and that is the oxygen. Okay, so remember our oxygen molecules is called a diatomic molecule because we always have two atoms which are bonded together. Okay, so we'll have a rearrangement of atoms of the reactants in order for products to form. And we have another example here, which is basically showing us how water is formed. So we'd have our hydrogen, right, which is indicated by the red circles, and as well as our oxygen, which in this example at the bottom is indicated by our white circles. Okay, and they form to give us our water molecule, which we know as H2O. All right. Okay, do we have a question? Okay, so Tyrese, like that makes salt, right? That makes salt. Is it eatable? Yes, the salt is eatable. The table salt that we use is NaCl. All right. And Natalie, that is bad advice. That is bad advice. Tyrese, don't make the salt, please. Just buy it. It's much better like that. All right, so guys, this is how the water molecules are formed. So just note that, guys, that we have a rearrangement of atoms of reactants in chemical reactions. All right. Okay, so critical question. When do we know that a chemical reaction has taken place? So guys, an important thing, remember in chemical reactions, as I said, it involves breaking down, which is referred to as decomposition, or the synthesis, which is the building up of compounds. Okay, so either have a breakdown of our reactants or we have a build up of our reactants. So that is also just a simple explanation of chemical reactions. All right. So another thing that we can also note that can help us to basically see if a chemical reaction has taken place is if there is a change in the appearance of the substance. Okay, so if we have a new visible substance, then we can say that a chemical reaction has taken place. If we can smell something, like if there's a new odor that's forming, then we can definitely say that a chemical reaction has taken place. If we have a change in temperature, then we could say that a chemical reaction has taken place, but not always. All right, guys? And as well as if we have a sound that is forming when we are mixing two substances, then we can say that a chemical reaction has taken place. All right, so when having a chemical reaction, one of these 5 things will occur. All right, so either have a change in the appearance of the substance, you'll either see a new visible substance, you'll either smell something, there will be a change in temperature, or there will be a weird sound that is going on. All right. Then let us look at a fermentation as a chemical reaction. So remember when we read the key questions, we were told, or rather we were asked to about indigenous chemical reactions, right? So fermentation is one of those indigenous chemical reactions that have been taking place. So it is a chemical process by which molecules such as glucose are broken down and aerobically, right? Fermentation does not only produce unwanted products, but the yogurt that we eat, the buttermilk, the cheese are all fermented milk products, all right? Then in these examples, the fermentation process creates acids that give these foods a sour taste. Remember the acid that we spoke about, the lactic acid, which forms when milk expires? Yeah, that is what gives these foods that sour taste. Okay, so here we have the different dairy products which are made using fermentation. So we have our cheese, our yogurt, and that looks like amazi. And on the right-hand side, we have 2 buckets of ginger beer, which are fermenting. Tari says yogurt has good bacteria. Yes, it does. Plain yogurt, to be exact. So yeah, here we have the 2 buckets of ginger beer fermenting. All right. Then we have an activity. It says study the fermentation reaction. Okay? So the basic reaction in the fermentation process can be summarized as follows. Glucose, right? It reacts to give us alcohol and carbon dioxide. So question is, what are the reactants and products in this reaction? The glucose giving us alcohol plus carbon dioxide. And the question is, what are the reactants and products in the reaction? Let's start off with the reactants. What are the reactants in the chemical formula above? What are the reactants in the chemical formula above? So we're referring to the activity, now guys. Just send through your answers to the chat. Okay, I see Mike says alcohol and carbon dioxide, right? Do we have any different answer? Chedza says glucose and alcohol. Okay. All right. So guys, I think Natalie, wow. All right. So guys, I think I should just quickly say this. Now, I don't think I said it. So every time, you see, we always have an arrow, which is distinguishing between our products and our reactants. On the left-hand side of the arrow always indicates the reactant. All right. The left-hand side of the arrow always indicates the reactant. Okay. So in this case, our reactant would be glucose, and then the product that are formed is alcohol and carbon dioxide. Okay. Are we all following? The left-hand side always indicates our reactants. So that is just a simpler way to basically remember this. All right. So glucose is our reactant. Are we all following, guys? Great. Beautiful. Okay. So as we said, guys, that our reactant is glucose and our products would be the alcohol and the carbon dioxide. Okay, so then let us continue with the activity. It says we can draw pictures of the molecules to show how the atoms are rearranged during the reaction. So on the left-hand side here, we have the molecule of glucose, the glucose molecule which is formed, and then on the right-hand side of the arrow, we have our alcohol, which is shown there, and as well as our carbon dioxide molecule, which is formed. And it continues to say that in the diagram above, the gray atoms are carbon, which is represented by the letter C, and the red atoms are the oxygen, represented by the capital letter O, and the small white ones are the hydrogen, okay, which is represented by the capital letter H. So write in the names of the compounds in this reaction. We already have it above. Okay, so glucose does not change into alcohol and carbon dioxide by itself, right? So microorganisms like yeast and bacteria actively ferment glucose. In South Africa, a popular drink is ginger or pineapple beer. The fizzy bubbles in the ginger beer or pineapple beer are bubbles of carbon dioxide produced by the yeast during fermentation. And it says, let's go make some ginger beer. All right. So I don't know if most of you guys, whoa, Tanisha, alcohol, like what we drink. You're not supposed to be drinking alcohol, Tanisha. How? I don't know if you guys have actually been in or rather seen people make pineapple or ginger beer, especially in this time, because it's been quite a popular drink that was being made in households. So we're just gonna go through this activity. Okay, so let me just get a picture here. All right, so basically we're gonna look at the ingredients that we used. Ne? We used water, okay? We used raisins, that is to make ginger beer. Ne? We used raisins in this case. We used yeast, and we also used sugar, okay? So that is to make our ginger beer. And if we just go back here, here we have at a later stage, maybe like after 2 or 3 weeks of letting the ginger beer ferment, we get a product like this. If we can see here, the 2 buckets of ginger beer fermenting, that is how this particular product would look like in 2 or 3 weeks time. Okay, so the instructions we have, it says that you need to research how to make traditional South African ginger beer, identify the different ingredients you will need, and once you have done so, you can decide as a class about the best recipe and then answer the questions that follow. So we are going to answer a few questions. I think we have a question here. It says, what percentage of alcohol does ginger beer have? That would depend on how long you let it ferment for. Okay, so that will depend on the duration of fermentation. Kids, it's okay, favor gift. You are welcome in class. Right, so let us look at the question that we have. So first question, what are the reactants in the reaction to make ginger beer? What are the reactants in the reaction to make ginger beer? And I think some of those reactants, you can see them from the picture. Okay, I think Tyrese, ma'am, people died from trying to make pineapple drink lately because, are you asking, is it because of the yeast? Oh, well, every drink, okay, not every, some people use substitute compounds, but I don't think it was because of the yeast. It was probably because of a food poisoning and making that drink in questionable hygiene spaces. All right, so guys, I need the answer to what are the reactants in the reaction to make ginger beer? What are the reactants in the reaction to make ginger beer? Can send through your answers, guys. The reactants to make ginger beer. Remember we said that we are using the raisins, okay? We also have water, we also have glucose, all right, guys? So I didn't see any answers in the group chat. So here is the answer. The chemical reaction occurs between sugar and fermenting fruit and the yeast. So the reactants are the sugar and the fruit, all right, which could be our ginger and raisins as well as pineapple in other recipes, okay? Right, then the next question. What is the product in the reaction taking place in the ginger beer? What is the product in the reaction taking place in the ginger beer? The product in the reaction taking place in the ginger beer. All right. So yes, guys, the product is a carbon dioxide and a very small amount of alcohol. I can't remember who asked about the alcohol percentage. So guys, again, the alcohol percentage is dependent on how long you leave your brew to ferment. All right. Okay. The next question, why are there fizzy bubbles in the ginger beer? Why do we have fizzy bubbles in the ginger beer. Okay, guys, just to make you aware, I don't have access to the chats anymore, but I will read to you guys the answers. All right. So why we have fizzy bubbles in the ginger beer is because the carbon dioxide gas that is trapped in the liquid, right? So just refer to the chemical formula that we have above. They're just which says, sorry, glucose gives us alcohol and carbon dioxide. So that is basically the answer to this part, all right? It is carbon dioxide that is trapped in the liquid. Okay, then the last question, where do you think the gas comes from? So remember the gas is carbon dioxide that we are referring to, or rather that is forming. And yes, guys, the gas is as a result of the chemical reaction between the yeast, the sugar, as well as the fermenting fruit. So again, just note that the fermenting fruit, guys, it can either be our raisins or pineapple, right? And that is used because yeast needs to break down sugar in order to form alcohol and carbon dioxide. Okay. Then guys, just another thing as well is that chemical reactions can help us detect certain substances. Okay, so just a simple explanation. I think you guys did this during respiration in life and living, the topic of life and living. If you have clear lime water, all right, if you have clear lime water and you basically use a straw to blow in your air into the clear lime water, the lime water would turn milky. All right, and that basically indicates that there is a presence of carbon dioxide in the air, which was basically breathed into the clear lime water. Okay, so here, guys, we have an example of ammonium dichromate, which burns in oxygen. And this reaction basically produces bright orange sparks. So the ammonium dichromate and is usually used in volcano experiments, right? So then the reaction would form nitrogen gas, water, and a dark green compound called chromium oxide as the product. And you can see the chromium oxide here on the picture on the right. It's the one at the bottom. And this reaction is unique because only ammonium dichromate reacts with oxygen to form these particular products. So if the ammonium dichromate reacts, then we know that we have a presence of oxygen in the space. All right. So guys, just to sum up what we have learned today is that chemical reaction, okay, that is when one or more parts of a chemical compound interact with one or more parts of another chemical compound to form substances that are different. All right. And then we have reactants, which are usually found on the left-hand side of our arrow, and our products, which are usually found on the right-hand side of our arrow. Okay, and guys, remember again, the reactants are the substances used, okay, in order for the chemical reaction to take place, and then the products are the substances produced by the chemical reaction. Another important fact, guys, that we need to note is that physical change, that is the composition of compounds, stays the same. And then when we have a chemical change occurring, that is when we have a change in the composition of compounds. All right. So guys, that brings us to the end of our lesson. So guys, in this lesson, we used the Siyavula Grade 8 Natural Science textbook, and we also used the Oxford Successful Natural Science textbook, as well as the ACID study guide. And again, just a reminder that you guys can also get yourself these textbooks and study guide from Snaplify. You just need to download the app from your Play Store. All right. So guys, if you do have any questions or queries or suggestions, please do drop me an email at unkarabetse.sits@gmail.com. And please remember to follow Africa Team Gigs on all their social media platforms. So guys, unfortunately, I can't see the chats right now. So if you did have any questions, then can you just post them, or rather, can you please email them to me? And then I will give you an answer. So tomorrow, guys, we are continuing with revision. We'll do term 1 revision. We're going to start at photosynthesis. All right. So guys, thank you very much for joining me in class. Have a good day further. And yeah, remember to study and keep warm. Bye, guys.